It didn't arrive with fire, no roar, no warning, just a quiet line of numbers, sliding across a screen at an observatory late at night. At first, no one even looked twice. Another object, another visitor, passing through the dark. That's how space works, after all. Things drift in, things drift out. But this one had a name almost immediately. 3I/Atlas, the third interstellar object ever detected passing through our solar system. And from the moment it appeared, it felt different, not dramatic, not loud, just precise. Far beyond the orbit of Mars, beyond the familiar paths we've memorized over decades, astronomers saw it cross the ecliptic plane, the invisible flat disk where planets move around the sun. That alone wasn't strange, but the way it crossed was. Its path was clean, too clean. A straight, confident line cutting through space, like it knew exactly where it was going. No wobble, no hesitation. Just speed and direction. As if 3I/Atlas had already made this journey before. The computers marked it as routine. The software labeled it expected behavior. And yet, something felt off. Because when scientists pulled the first real data, not the summary, not the filtered version, but the raw numbers, there was a strange silence in the room. The kind of silence that only happens when people are trying to convince themselves nothing is wrong. The object was moving fast, faster than most comets, faster than debris kicked loose by dying stars. Fast enough that gravity didn't seem to grab it the way it should, as if the sun's pull was anticipated, predicted. 3I/Atlas wasn't falling inward, it was passing through. Like a visitor who never planned to stay. And still, no alarms were raised, because science teaches patience. You don't panic over a single data set. You don't chase ghosts in early readings. So astronomers did what they always do. They waited. Night after night, telescopes across the world turned quietly toward the same point in the sky. Hawaii, Chile, the Canary Islands. Different instruments, different teams, same object, same trajectory. And slowly, something strange began to form. Not an error, not noise, but absence. There were gaps where there shouldn't be any. Moments where the object should have been brighter, but wasn't. Moments where it should have shifted slightly, but didn't. It was subtle, the kind of thing you miss if you're not looking for it. And why would you look for it? After all, comets don't plan. Asteroids don't decide. They tumble. They react. They are slaves to gravity and chance. But 3I/Atlas didn't feel reactive. It felt intentional. Still, no one said that out loud. Because saying it would sound foolish. Instead, they checked calibration. They checked mirrors. They checked timing. They checked themselves, again and again. Everything came back clean, which made the silence heavier. Because the more accurate the instruments became, the less complete the picture felt. There was no coma, no glowing cloud of gas and dust like a normal comet, no tail stretching behind it like a banner, just a compact source of reflected light, cold, contained, almost reserved. As 3I/Atlas moved closer, approaching perihelion, its closest point to the sun, the expectation was simple. Heat would wake it up. Ice would crack. Gas would bloom. Something dramatic. That's what happens when ancient objects meet sunlight for the first time in millions of years. But this one stayed quiet. No outburst, no shedding, just movement. Steady, measured, like it was conserving something. And that's when a question quietly passed between researchers without ever being written down. What if this isn't incomplete data? What if this is all there is? The idea was uncomfortable, because astronomy depends on patterns. We understand the universe by repetition. We predict behavior because we've seen it before. But 3IATLAS didn't fit the old shelves. It didn't demand attention. It didn't beg for explanation. It simply existed, crossing the solar system like a stranger walking through a familiar town. And the strangest part, its timing. Out of all the directions it could have come from, out of all the angles through the vast emptiness of space, it crossed the ecliptic at a near-perfect alignment, close enough to be studied, close enough to be noticed, not close enough to cause fear, almost considerate. Astronomers would later say that was coincidence. Statistics allow for rare events, but even rare events have fingerprints. And this one left behind something hard to explain. Confidence, not in intention, but in motion. 3IATLAS moved like it trusted its path, as if nothing in this system could surprise it, as if it already knew where the planets were, where the sun would be, how gravity would bend space around it. That thought stayed buried, unspoken, because science doesn't ask why before it asks how, and how was already becoming difficult. As the days passed, the object continued inward. No change in spin, no erratic behavior, just that same quiet precision. And somewhere between the calculations and the coffee cups, someone noticed something small. A discrepancy so tiny, it almost wasn't worth mentioning. Almost. The predicted position and the observed position didn't perfectly match. Not by much, just enough to suggest correction, a whisper of adjustment, the kind you would expect from a system responding to feedback, not from a rock, not from ice, not from something dead. The room didn't panic. No headlines were written, but the feeling changed. The discovery phase was over. Now came the watching. Because whatever 3IATLAS was, it wasn't rushing. And it wasn't lost. It was arriving. Quietly, deliberately. And the closer it came, the more it felt like the data wasn't missing at all. It was waiting for something else to notice it. At first, it looked like a mistake. Just a small bend in a line on a graph, something easy to ignore. Astronomers call it a light curve. It's simple, really. You watch how bright an object gets, then how dim it becomes over time. For comets, the story is familiar. They spin, they tumble. One side faces the sun, heats up, glows brighter. Then it turns away, cools down, fades. Up and down, a smooth rhythm, predictable, comforting. That's how we know what they are. But when the light curve of 3IATLAS came in, it didn't tell that story. The brightness rose sharply, then fell too slowly, then rose again, but not to the same level. No mirror, no balance, no symmetry. Just uneven peaks and shallow valleys, like something was interrupting the cycle. At first, scientists blamed rotation. Maybe it was spinning oddly. Maybe its shape was strange. Long, flat, jagged. Nature makes weird things all the time. So they ran the models: fast rotation, slow rotation, chaotic tumble. Nothing fit. No matter how they adjusted the math, the curve refused to behave. And that's when the discomfort began. Because light curves are honest. They don't lie. They don't care what we hope to see. They just show how light reflects, how surfaces respond, how objects exist in space. And this one was inconsistent, almost selective, as if 3IATLAS was choosing when to shine. Some nights, observatories saw it brighten unexpectedly. Other nights, it dimmed when it should have glowed. Not randomly, not wildly, just deliberately uneven. The data teams double-checked everything: atmospheric interference, instrument noise, human error, different telescopes, different continents, different skies. Same result. The light curve was wrong everywhere. That's when someone asked a quiet question. What if we're not seeing rotation at all? What if we're seeing response? That idea didn't land easily, because response implies awareness. And awareness doesn't belong in comet science. Still, the curve kept coming back, each new dataset adding weight. The brightness didn't drift smoothly. Paused, shifted, almost like a heartbeat that refused to settle into a rhythm. Astronomers started overlaying timelines: solar flares, magnetic changes, radiation spikes. Was the object reacting to something? The answer should have been no. Comets don't react, they endure. But every time the sun's output changed, even slightly, the light curve of 3I/Atlas responded. Not instantly, not perfectly, but enough to raise eyebrows, enough to make rooms go quiet. Because the timing was thoughtful, not rushed, not delayed, measured. As if something was filtering the input before allowing the surface to reflect more light. That's not how ice behaves. Ice cracks. Ice erupts. Ice doesn't hesitate, but this object did. The reflectivity shifted in patches. One side brightened, while another stayed dark. Then they swapped. Not smoothly, in sections, as if different parts followed different rules. That's when the word anomaly started appearing in internal notes. Not public, not yet, just between people who knew how dangerous that word could be. An anomaly is science's warning sign. It means the map no longer matches the territory, and this map was falling apart. Some suggested dust clouds, thin veils that blocked light unevenly. But dust behaves like smoke, messy, unpredictable. This wasn't messy, this was clean, almost edited. Others suggested shadowing from an irregular shape, but shadows repeat. They don't improvise, and 3I/Atlas seemed to improvise constantly. Then came the hardest suggestion to dismiss. What if the light curve isn't passive? What if it's being controlled? That thought didn't need to be said aloud. It hung in the air anyway, because control implies design, and design implies purpose. But no one wanted to go there, so they tried something safer. They compared it to everything we've ever seen. Oumuamua. 2I/Borisov. Long-period comets, near-Earth asteroids. Nothing matched. Some were chaotic. Some were smooth. None were selective. None showed this strange sense of restraint. As days passed, the curve grew more complex, not noisier, more structured. Small repeating features began to appear, not exact copies, close cousins. Like variations on a theme, enough to suggest pattern but not enough to prove it. And that's the cruel part. The universe rarely gives clear answers. It gives hints, teases, just enough to make you doubt your own certainty. Publicly, nothing changed. Press releases stayed calm. Routine tracking, ongoing observation. But privately, scientists started watching the light curve, the way doctors watch a heartbeat monitor. Waiting, wondering, because if this was just perception, the pattern would collapse eventually. Randomness always reveals itself, but if something was shaping it, if something was choosing how light moved across its surface, then the curve would grow stronger, clearer, more confident. And that's exactly what began to happen. The rises became sharper, the falls more deliberate, almost like punctuation, as if the object was saying something, not in language, in physics, in brightness and shadow, in presence and absence. And the scariest part? It didn't seem to care who was watching. The pattern didn't change when we looked harder. It didn't hide. It didn't exaggerate. It just continued, unbothered. Like it had always behaved this way, long before humans ever pointed mirrors at the sky. That realization hit quietly. This wasn't a performance. It wasn't reacting to us. We were reacting to it. And that flipped everything, because for the first time, it felt like we weren't discovering something new. We were catching up, watching something ancient, something practiced, move through our system without adjusting its habits. The light curve refused to behave, because it wasn't meant to. It wasn't broken. It was consistent with rules we don't yet understand. And as 3IATLAS continued its silent approach toward the sun, the question grew heavier with every passing night. Are we misreading a natural object, or are we witnessing the surface behavior of something shaped, not by chance, but by intention? And if light can be shaped, what else can be controlled? That question lingered, waiting for the next set of data to answer it. At first, no one wanted to believe it, because space is noisy, always has been. Stars flicker, sensors drift, cosmic radiation whispers through every instrument we've ever built. So when the brightness of 3I/Atlas began to twitch, just slightly, the assumption was simple. Noise, background chaos, bleeding into clean data. Something to smooth out later, something to ignore. But then it happened again and again. Same rise, same fall, same timing. Not exact to the millisecond, but close enough to make people stop typing. A pulse, faint, measured, like a slow breath taken in the dark. At first, it hid inside the mess, buried beneath static and fluctuations. You wouldn't see it unless you were looking very closely. And even then, you'd doubt yourself. So scientists did what they always do when doubt creeps in. They refined. They filtered the data, removed atmospheric interference, stripped away known sources of error. Each pass should have flattened the curve. Each refinement should have erased the twitch, but instead, the pulse became clearer, stronger, as if removing the noise didn't destroy the signal. It revealed it. That's when the rooms got quiet again. Because randomness doesn't survive refinement. Patterns don't sharpen by accident. The brightness of 3I/Atlas wasn't just rising and falling. It was doing so on a schedule, not perfectly regular, but consistent. A slow increase, a pause, a gentle decline. Then silence. Then it happened again and again. A rhythm began to form. Not the frantic rhythm of a spinning rock, but something calmer, intentional, like a lighthouse rotating just out of sight. Astronomers overlaid the pulse with everything they could think of: rotation rates, solar wind pressure, magnetic field fluctuations. Nothing lined up. The pulse didn't match the sun. It didn't match known comet behavior. And most unsettling of all, it didn't drift. Natural rhythms wander. They stretch, they compress. This one stayed loyal to itself, even as distance changed, even as observation angles shifted. The timing remained. Not rigid, but disciplined. That word showed up quietly in private notes. Disciplined. As if the object wasn't just responding, but regulating. And regulation is a dangerous idea, because regulation implies thresholds. It implies limits. It implies something deciding when enough is enough. One researcher described it as brightness with restraint. A strange phrase, but it fit. 3IATLAS could have flared brighter. The physics allowed it. But it didn't. It pulsed, then stopped, like it was conserving something. Energy, structure, purpose. And once that thought enters the room, it doesn't leave easily. The pulse wasn't fast enough to be communication, not slow enough to be random. It lived in an uncomfortable middle space, a heartbeat that didn't belong to a body, that didn't feel lifeless either. As days passed, more observatories confirmed it. Independent teams, independent software. Same pulse, same rhythm. Far away, different skies. That's when the phrase global anomaly quietly appeared. Because when everyone sees the same impossible thing, it's no longer a local error, it's a shared problem. Some suggested internal heating cycles, maybe trapped gases releasing in stages. But gases don't keep time. They burst, they vent. They don't wait patiently between releases. Others pointed to shadowing effects, maybe rotating structures blocked and revealed light. But rotation leaves fingerprints. This pulse left none. It didn't speed up. It didn't slow down. It simply repeated. And the most unsettling part? The pulse didn't care about observation. It didn't align with Earth's rotation. It didn't shift based on viewing angle. It existed independent of us, as if we were overhearing something not meant for us. Late one night, a junior analyst did something simple. They counted, not equations, not models, just counted the intervals. And the gaps between pulses were close. Not perfect, but close to equal. Close enough to trigger a chill, because equal spacing is rare in nature. Chaos loves variation. Nature improvises. This didn't. The pulse felt trained, like a metronome buried under layers of dust and distance. Still, no one said the forbidden word. Not yet. Because saying it would change everything. Instead, they asked safer questions. Could this be resonance? Some natural oscillation we don't understand yet? Maybe. But resonance amplifies. It grows louder. This pulse stayed polite, contained, almost cautious, as if it knew how bright was too bright. That idea scared people more than any flare ever could, because fear comes from violence. This felt like control. The brightness rose, held, then faded. Over and over. No panic, no excess. Just timing. And timing is the language of machines. That realization didn't come all at once. It crept in through the back door, in quiet glances, in unfinished sentences, in the way people stopped laughing during breaks. Because if this was a machine, then it wasn't announcing itself. It wasn't shouting. It wasn't signaling in radio waves or lasers. It was simply existing, maintaining itself, passing through. And we just happened to notice the pulse, like hearing footsteps in another room, and realizing someone has been there the whole time. Some argued we were projecting. Humans love patterns. We see faces in clouds, meaning in noise, and that's true. But this wasn't a cloud. This was math, cold, unforgiving. Numbers don't imagine. They repeat what's real. And the repetition refused to go away. As 3I/Atlas drew closer to perihelion, the pulse didn't break. Solar radiation increased. Gravitational stress intensified. Any fragile system should have faltered. This one didn't. If anything, the timing became cleaner. As if pressure didn't disrupt it, it confirmed it. That's when the question stopped being academic and started becoming personal. If randomness fades and timing remains, what are we actually looking at? A natural object performing an impossible balancing act, or a system designed to survive interstellar space? By controlling how it interacts with energy, no one had proof. Not yet. But proof wasn't the problem anymore. The problem was comfort. Because the pulse didn't feel ancient, it didn't feel dead. It felt ongoing, active, as if 3I/Atlas wasn't a relic, but a process, still running, still counting, still moving through the dark with quiet patience. And as the data streamed in night after night, one truth became harder to ignore. We weren't watching chaos settle into order. We were watching order reveal itself. As we slowly stripped chaos away, the pulse beneath the noise wasn't disappearing. It was waiting for us to listen closely enough. And once you hear a rhythm like that, you can never unhear it, because it raises a question that refuses to rest. If this pulse is intentional, if this timing is deliberate, then 3I/Atlas isn't just passing through our solar system. It's doing exactly what it was built to do, and we haven't even begun to understand why. At first, it was the shine that caught their attention, not how bright it was, but when it chose to be bright. Because reflectivity is supposed to be simple. Light hits a surface, some of it bounces back, some of it disappears. Ice reflects sharply. Rock absorbs more. That rule has held for everything we've ever studied. Until 3I/Atlas. As the object continued its slow rotation, telescopes tracked how sunlight scattered across its surface. And the readings came back wrong. Not wildly wrong. Uncomfortably wrong. One moment, the surface reflected light with a sharpness closer to polished ice. The next, it dulled down, darker than bare stone. Then it brightened again, but not evenly, not smoothly, in patches, like sections of the surface were taking turns. Choosing. At first, scientists assumed mixed materials, maybe ice pockets embedded in rock, maybe dust layers shifting as it spun. A messy surface could explain messy reflections. But this wasn't messy. The transitions were clean. Too clean. Reflectivity didn't fade gradually. It switched. Bright. Dim. On. Off. As if different regions followed different rules. And the more closely they watched, the stranger it became. Because those reflective spikes didn't line up with the object's rotation in a normal way. They lagged, then caught up, then paused, almost like the surface wasn't just turning, it was responding. That idea made people uneasy. Because response implies sensing, and sensing implies awareness of conditions. But no one wanted to say that yet, so they dug deeper. They measured angles, compared how light scattered at different wavelengths, infrared, visible, near, ultraviolet. Each band told the same unsettling story. The surface wasn't uniform, but it also wasn't random. Some areas reflected like metal, but without the spectral signature of metal. Others absorbed heat like carbon-rich rock, then suddenly changed behavior. No melting, no cracking, just adjustment. As if the skin of 3IATLAS wasn't passive. As if it wasn't just sitting there taking whatever the sun threw at it. As if it was managing exposure. That's when someone used a phrase that would quietly spread through the community. Active surface behavior. Not geological, not chemical. Active. The words sat heavily on the page, because active surfaces are rare. On Earth, they belong to life or machines, not interstellar objects drifting alone between stars. Still, there were attempts to ground the idea. Maybe it was a thin layer of exotic ice, something we haven't seen before. But exotic ice still obeys thermodynamics. It doesn't decide when to reflect more light. It doesn't hold back. And yet 3I/Atlas seemed to do exactly that. As the object approached perihelion, the sun's glare intensified. Radiation pressure increased. Most surfaces would brighten steadily under that assault. This one didn't. Instead, reflectivity peaked, then dropped, as if the surface was shielding itself, like sunglasses sliding down over ancient eyes. That metaphor wasn't scientific, but it felt accurate, because the surface behavior felt protective, controlled, intentional. The reflectivity spikes weren't dramatic. They weren't meant to impress. They were just enough. Enough to manage heat. Enough to survive. And that raised a quiet but terrifying question. What kind of origin produces a surface that manages energy? Nature tends to overreact. It erupts. It fractures. It doesn't optimize. But optimization is a hallmark of design, and design implies time, planning, iteration. Someone or something had to test what worked, had to learn which surfaces reflect too much, which absorb too little, had to refine. That thought made people uncomfortable, because it suggested history, not just age, but experience. As if 3I/Atlas wasn't just old, it was seasoned, veteran. As days passed, the reflectivity pattern grew clearer. The bright patches appeared at similar solar angles. The dull regions activated when exposure peaked, almost like a feedback loop. Sunlight increased, surface darkened. Sunlight decreased, surface brightened. A thermal dance. Not perfect, but deliberate. And deliberate behavior doesn't belong to dead things. That realization didn't hit like a shock. It settled in slowly, like a weight. Because once you accept that the surface might be managing energy, you have to ask why. Why would an object drifting through interstellar space need that level of control? What dangers had it already survived? What stars had it passed? What radiation storms had it endured? That taught it to behave this way? Some argued this was projection again, humans assigning meaning to physics. But physics doesn't hesitate. It doesn't delay. It doesn't choose. This surface did. And the more the data came in, the harder it was to deny. The reflectivity changes weren't just about light. They affected temperature. They affected the pulse. They affected everything. Like the surface was part of a larger system, a skin, not a shell. Something designed to interact with the environment, not just endure it. That idea quietly shifted the conversation, because if the surface was engineered, then the interior mattered. And if the interior mattered, then 3I/Atlas wasn't just an object. It was a structure. The thought lingered. Unspoken, dangerous, but impossible to erase. As the object rotated silently against the star field, its skin continued to flicker, not wildly, not chaotically, just enough to say, "I'm here. I'm still working." And that was perhaps the most haunting part. The reflectivity didn't degrade. It didn't wear down under solar assault. It stayed consistent, reliable, like a tool doing exactly what it was built to do. Long after its makers, if there ever were makers, had vanished. That realization hit late one night, in the quiet glow of monitors, when someone noticed that the reflectivity pattern hadn't drifted over weeks. No erosion, no decay, just continuity. And continuity in space is rare. Space breaks things. Time erodes everything. Unless something is built to last. As 3I/Atlas moved onward, its surface kept choosing when to shine and when not to, unbothered by attention, unchanged by interpretation, just rotating, reflecting, adjusting, like a machine that doesn't care if you understand it, as long as it keeps doing its job. And that left scientists with a question that felt heavier than all the others combined. If this is just the skin, what lies beneath it? And what purpose requires a surface that knows exactly when to face the light and when to turn away? It started with a number that shouldn't exist. Not a spike, not an explosion. Just a quiet change in temperature. Thermal sensors watching 3I/Atlas began to report something subtle but impossible. The surface warmed, then cooled. Without moving closer to the sun, no change in angle, no change in shadow. Just heat, appearing, and then disappearing. At first, the assumption was simple: instrumentation error. Thermal readings are delicate. They drift, they lie sometimes. So the data was flagged, checked, then checked again. Different sensors, different observatories. Same result. The temperature of 3I/Atlas was changing, when it shouldn't. In space, heat follows rules. Closer to the sun means warmer. Farther means colder. Shadow cools. Light heats. Those rules are not suggestions. They are laws. And yet, this object didn't care. One section of the surface warmed rapidly, while another stayed cold. Then, minutes later, they swapped. No visible plume, no outgassing, no rotation explanation that fit. Just heat moving, like it was being routed. That's when the discomfort turned real. Because temperature is honest. You can fake brightness. You can misread motion. But heat doesn't pretend. Heat reveals work, energy being spent, something doing something. As 3I/Atlas moved inward, nearing perihelion, expectations were clear. Solar radiation should dominate everything. Any internal behavior should be drowned out by the sun's glare. But instead, the internal pattern became stronger. The object didn't heat evenly, it regulated. Some regions cooled themselves despite direct sunlight. Others warmed while facing darkness. That shouldn't happen. Not naturally. Not without an internal source. And that's the phrase that stopped conversations mid-sentence. Internal source. Because internal sources don't belong in comets. They belong in reactors, in engines, in things that consume energy and decide how to release it. Scientists tried to explain it away, maybe delayed heat transfer. Materials holding warmth longer than expected. But delayed transfer smooths temperature curves. This didn't smooth. It jumped, sharp transitions, clean edges, as if heat was being turned on, then off. Someone overlaid the thermal data with the light pulse, and the room went silent. They matched. Not perfectly, but close enough. When brightness pulsed, heat followed. When reflectivity shifted, temperature adjusted. Like multiple systems were talking to each other, coordinating. That's not geology, that's architecture. The idea felt dangerous, so people resisted it. They pushed harder on natural explanations, exotic materials, unknown phase changes, maybe something new. But even new physics has limits. It still obeys causality. Energy doesn't move without reason, and here the reason was missing. Or worse, hidden. Because the heat wasn't excessive. It wasn't reckless. It stayed within safe margins. Never enough to damage the surface. Never enough to trigger visible activity. Like it was carefully budgeted, conserved. That's when someone said it quietly. Whatever this is, it's efficient. Efficiency is not random. Efficiency is learned, designed, refined. And refined things don't happen by accident in interstellar space. The sun continued to batter 3I/Atlas with radiation. Any fragile structure should have failed. Cracked, warped. This one didn't. Instead, its thermal behavior became more disciplined, more stable. As if stress wasn't harming it, it was testing it. And the object was passing. The heat shifts followed patterns, not repeating exactly, but adapting. Small corrections, feedback. That word showed up again, feedback. A system sensing its own state and adjusting. That idea crossed a line. Because feedback systems don't exist without intention. They exist to maintain balance, to survive environments that would otherwise destroy them, which begged a question no one wanted to answer. What environment was this built for? Interstellar space is brutal. Radiation storms, temperature extremes, loneliness measured in millions of years. Anything that survives there doesn't just drift. It prepares. And 3I/Atlas felt prepared. The thermal pattern wasn't chaotic. It wasn't desperate. It was calm, measured, like the object had been here before. Seen stars like ours, felt this kind of heat, and knew exactly how much was too much. That realization crept in slowly. And once it did, it changed everything. Because if the heat was controlled, then the pulse wasn't random. The reflectivity wasn't cosmetic. The light curve wasn't broken. They were all pieces of the same system. A surface that managed light, an interior that managed heat, a rhythm that managed timing. Not independent anomalies, but components. Working together, the thought settled like a weight on the chest, because components imply construction, and construction implies an origin that isn't blind. Someone asked the question everyone feared. If it's controlling heat, what's powering it? No one answered, because there was no good answer. Solar energy didn't explain it. The timing didn't match. Stored heat didn't explain it. The changes were too responsive, too aware of conditions. That left only one option: an internal energy source, not explosive, not loud, just persistent, enough to regulate, enough to endure, enough to stay alive. Alive isn't the right word, but no, one could find a better one. As 3I/Atlas continued its silent journey, the heat shifts kept happening, unconcerned with our confusion, unimpressed by our models, just doing what they had always done. And that was perhaps the most unsettling part. This wasn't new behavior. We were just late to notice it. Late to understand that the object wasn't warming because it was close to the sun. It was warming because it chose to. And once you accept that, once you accept that heat itself might be regulated, the universe feels very different. Because heat is survival. Heat is control. Heat is work. And something out there, far older than us, far quieter than us, was doing work. In the dark, without ever asking to be seen. As the data streamed in, one truth became unavoidable. If no natural process explains the thermal pattern, then nature isn't in control here. Something else is. And whatever it is, it's still active, still thinking, still managing its own existence, as it passes silently through our solar system, leaving us with a question that burns hotter than any star. If this object controls its heat, what else does it control? And why is it here? Now? Everyone was waiting for this moment. Not because they wanted answers, but because they expected an ending. Perihelion, the closest point to the sun. The place where comets either bloom or break. History had trained them well. Ice cracks. Gas explodes outward. Tails stretch like screams across the sky. Perihelion is violence. It is stress written in heat and light. So when 3I/Atlas approached that line, that invisible boundary where survival becomes unlikely, scientists leaned forward. Because if this object was fragile, if it was just another strange rock wrapped in mystery, this is where the truth would tear it apart. Models were clear. Thermal load would spike. Structural weakness would show. Mass loss was inevitable. Something would give. It always does. The sun doesn't negotiate. Days before perihelion, instruments were recalibrated, every sensor sharpened, every telescope focused. If 3I/Atlas was going to fail, they would see it. The approach was quiet, too quiet. Brightness increased, as expected. Radiation climbed. But the surface didn't fracture. No plume of gas burst free. No tail flared into existence. The object held together. Calm, composed, like it had nothing to fear. That alone was strange. But the real shock came at perihelion itself, the moment when solar intensity peaked. When models predicted chaos, Nothing happened. No shedding, no deformation, no loss. The mass estimates stayed the same. The thermal readings stayed within controlled limits. The pulse didn't stutter. The reflectivity didn't collapse. 3I/Atlas passed its closest encounter with a star and behaved like it had rehearsed the moment. That's when disbelief set in. Because survival is one thing, stability is another. Comets can survive perihelion, but they pay a price. They lose material. They scar. They change forever. This object didn't. It emerged on the other side, unchanged. No visible erosion, no detectable damage, as if the sun was just another obstacle already accounted for. A quiet realization spread through the community. This wasn't resilience. This was tolerance. And tolerance implies design margins, built-in limits, a system made to operate under stress, not merely endure it. Someone compared it to heat shields, another to spacecraft hulls. No one laughed, because the comparison fit too well. The thermal data told a disturbing story. At peak exposure, the object didn't overheat. It redistributed energy, moved heat internally, then released it gradually. No spikes, no panic, just balance. Like a body regulating its temperature, or a machine protecting its core. That's when the word test started to feel wrong. This wasn't 3I/Atlas being tested by the sun. The sun was being tested by 3I/Atlas, and the object passed. As it moved away from perihelion, something else became clear. Nothing had been consumed. No fuel burned. No reserve depleted. The internal energy signature stayed steady, as if the encounter cost it nothing. That scared people more than destruction ever could, because destruction is familiar. Survival without consequence is not. Theories began to collapse under their own weight. Exotic ice couldn't explain it. Ice doesn't survive like this. Rock couldn't explain it. Rock fractures under thermal stress. Even metal would suffer, unless it was engineered specifically for this environment. And engineering requires foresight. Someone, late in a closed meeting, asked the question no one wanted to hear. What if perihelion wasn't a threat, but a checkpoint? The idea felt absurd, but once spoken, it wouldn't leave, because everything about this object suggested preparation. The pulse, the surface control, the thermal regulation. Perihelion wasn't a surprise. It was an expected condition. Something the object was meant to experience. That flipped the narrative completely. Because natural objects don't expect things. They react. They endure until they don't. But 3I/Atlas behaved like it had been built with this moment in mind. As if the designers, if there were designers, knew stars, knew heat, knew exactly how close was too close, and designed accordingly. That idea felt dangerous, not because it implied intelligence, but because it implied scale. Interstellar scale. Whoever, or whatever, created something like this, understood stars the way we understand weather, and that places them far beyond us. As 3I/Atlas continued outward, data from perihelion was analyzed again and again, looking for hidden damage, microfractures, anything. There was nothing. The object was as clean leaving the sun as it was approaching it. That's when definitions began to crack, because science relies on categories: natural, artificial, alive, inert. 3I/Atlas didn't sit comfortably in any of them. It wasn't alive, but it behaved like it wanted to remain intact. It wasn't artificial, at least no one could prove it, but it behaved like something designed to last. The perihelion test didn't reveal weakness, it revealed confidence. And confidence is unsettling when it comes from something that never speaks, never signals, never explains itself. Publicly, the language stayed careful. Unusual resilience, unexpected stability. But privately, something had shifted. The conversation was no longer about what this object was made of, but why it existed at all. Because nothing survives like this without reason. As the sun faded behind it, 3I/Atlas kept moving, outward, back toward the dark. And that direction mattered. It wasn't captured. It wasn't slowed. It didn't linger. It passed through our system, unaffected, as if this encounter was never the destination, just another leg of a much longer journey. That realization left a hollow feeling, because it meant we were not the focus, not the audience, not the reason. We were just in the way. The perihelion test was supposed to bring clarity. Instead, it erased comfort. Because if an object can survive what should destroy it, without loss, without change, then maybe our definition of natural is too small. Maybe nature is capable of things we've never imagined. Or maybe this isn't nature at all. As 3I/Atlas faded slowly from the sun's glare, one truth became impossible to ignore. Whatever this object is, it wasn't built for a single star. It was built for many. And that raises a question that no model can answer. If something can cross interstellar space, control its light, manage its heat, and walk unscathed past a star, then what was it really designed to do? And how many times has it already done it before? At first, no one was looking for shape. They were looking for damage, cracks, scars, anything perihelion should have left behind. But as the models grew more detailed, something else began to surface, not on the outside, beneath it, hidden under layers of dust and uncertainty. When scientists fed all the data into high-resolution simulations, motion, rotation, light, heat, the computer didn't just map behavior. It began to suggest form, and the form it hinted at made people uneasy. Because it wasn't organic, it wasn't chaotic, it was clean. Angles appeared where curves should have been. Ratios repeated across different models, not exactly the same, but close enough to rhyme, like echoes of a design language. At first, they blamed math. Algorithms love symmetry. They sometimes invent patterns that aren't real. So the teams changed the assumptions, removed constraints, introduced randomness. Let the object be ugly. Let it be wrong. But every time they loosened the rules, the shape came back. Not sharper, but stubborn. As if something beneath the dust insisted on order, the simulations began to show edges. Not literal edges you could draw with a ruler, but transitions, sudden changes in slope, unexpected flatness in places that should bulge, like panels hidden under debris. That word, panels, never appeared in official reports, but it floated in the room, uninvited, uncomfortable, because panels belong to machines, not to rocks that have drifted blindly for millions of years. Someone suggested it might be a shard, a broken piece of a larger body. Fragments can have strange shapes, but fragments don't explain repetition. They don't explain ratios. They don't explain why independent models kept landing on similar internal geometries. That's when one researcher did something simple. They stopped asking what it looked like and asked how it was built. They overlaid the inferred structure with known stress maps, where heat had flowed, where forces had been redirected, and suddenly it made sense. Too much sense. The stress pathways avoided certain regions, reinforced others. Like load-bearing zones, like something designed to carry force, not suffer from it. That realization didn't land with excitement. It landed with dread, because design implies intention, and intention implies an origin story far beyond ours. The angles weren't perfect, they weren't human. They didn't obey our sense of beauty, but they obeyed something deeper: efficiency, stability, purpose. Nature doesn't chase purpose, it stumbles into it. This felt chased, as if the structure beneath the surface had been optimized again and again, across distances we can't imagine. The dust layer suddenly felt like camouflage. Not intentional camouflage, just accumulation, like paint chipping off an old ship. As if time had tried to bury the shape and failed. The more data they added, the more the object resisted being rounded. It refused to become a smooth comet, refused to become a tumbling rock. It wanted to be something else, something rigid, something intentional. Someone finally asked the question that had been circling for weeks. At what point does an unknown pattern stop being unknown and start being artificial? No one answered, because answering would require a line, and no one wanted to be the one to draw it. Artificial is a heavy word. It changes headlines. It changes funding. It changes history. So instead, they danced around it. They used safer phrases: non-random structure, highly ordered geometry, unexpected internal consistency. But words don't hide truth forever, especially not when numbers keep repeating themselves. The ratios showed up again. Not simple ones like 2-to-1, more subtle, more elegant, the kind that emerge from engineering, not erosion. And erosion was losing its case fast, because erosion blurs. It softens. It doesn't preserve. Yet here was an object that had crossed interstellar space, survived radiation, passed a star, and still carried its shape. That alone was extraordinary, but the shape itself? That was unsettling, because it suggested containment, as if the object wasn't just a mass, but a housing, holding something, protecting something, or maybe transporting something. That thought didn't need to be spoken. It sat quietly between glances, between long pauses, between unfinished sentences. Because if this was a machine, it wasn't active in the way we expect. No signals, no propulsion, no obvious mission. But machines don't have to move to function. Some only wait. Some only endure. Some are built to pass through environments and keep going. The structure suggested modularity, sections that behaved differently, regions that handled heat, regions that handled stress, regions that stayed quiet, like systems separated by design. And that's when the last natural explanation cracked, because nature doesn't separate systems. It blends them. Chaos is its signature. This object resisted chaos. It compartmentalized, as if someone somewhere had asked a simple question long ago: what will survive longest? and then built an answer. That idea didn't feel like science fiction. It felt like engineering logic, cold, patient, unemotional, and terrifying in its simplicity, because whoever could build something like this understood time, understood stars, understood how to let something travel, not for years, but for ages. The shape of a machine doesn't have to look like gears and wires. It can look like restraint, like balance, like a refusal to break. And 3IATLAS refused to break. Even now, as it moved away from us, its inferred structure stayed consistent. No deformation, no collapse. Just quiet persistence. The models didn't scream, alien. They whispered, intent. And whispers are harder to dismiss. Because they don't demand belief, they invite doubt. The scientific community stood at an edge. On one side, unknown natural phenomenon. On the other, something built. And the distance between those two ideas was shrinking. Not because of imagination, but because of math. Because math doesn't care about comfort. It doesn't fear implications. It just keeps pointing again and again to the same conclusion. At some point, an unknown pattern stops being mysterious. It becomes specific. It gains character. It gains limits. And limits are fingerprints of design. As 3I/Atlas drifted farther into the dark, its shape remained, untouched, unchanged, like a question carved into the universe, waiting, because if this really is the shape of a machine, then it was never meant to be understood at a glance. It was meant to endure, to pass, to exist long after its makers or its purpose had faded into silence. And that leaves us with a thought that's hard to escape. If this object was built, then it wasn't built for us. We just happened to notice it. In the brief moment, it crossed our sky. And if we can see the shape now, how many others have passed before, still hidden, still intact, still moving, waiting for the moment when our tools become sharp enough to recognize them for what they are. The data didn't argue, people did. Across observatories, across time zones, across quiet video calls that stretched deep into the night, a line began to form. Not on paper, in minds. On one side were those who leaned back in their chairs and said, "Slow down." They spoke carefully, measured every word. Science moves forward by doubt, they reminded everyone. Extraordinary claims require extraordinary evidence. Maybe this was a statistical illusion. Maybe a rare but natural object. Maybe the universe was playing one of its cruel tricks, daring us to see meaning where none existed. And on the other side were those who leaned forward, who stared at the numbers too long, who felt the quiet weight of repetition. They didn't shout. They didn't claim certainty. They just said something simple. This is not behaving like anything we know. That's where the divide truly began. Not between belief and disbelief, but between comfort and curiosity. Because no one wanted to be reckless. No one wanted to rewrite textbooks on a hunch. But no one wanted to ignore what was right in front of them either. The meetings grew longer, more careful. Every sentence wrapped in conditions. If this holds, if further analysis confirms, if assumptions are correct, yet beneath all the caution, something else was happening. A quiet awakening. Scientists don't like the word awakening. It sounds emotional, messy. But that's exactly what it felt like, because the data wasn't getting weaker. It was getting stronger. Every attempt to flatten the anomaly only sharpened it. Every effort to explain it away added another layer of complexity, and complexity doesn't disappear by wishing. Still, no one wanted to be first. No one wanted their name attached to the wrong conclusion. Careers are fragile, reputations even more so. So the language stayed restrained, safe, unprecedented, unusual. Statistically significant deviation. But behind closed doors, the words changed. What if? How far does this go? What does this mean? Those questions echoed late at night, long after meetings ended, long after screens went dark. Because science isn't just equations, it's people. People who grew up believing the universe was silent. People who built their lives around that silence. And now something was disturbing it. The cautious voices warned of projection. Humans see faces in patterns, meaning in randomness. History is full of false alarms. They were right. Science survives because of skepticism. But skepticism has a shadow: fear. Fear of being wrong. Fear of ridicule. Fear of opening a door that can't be closed. The awakening voices weren't reckless. They didn't claim answers. They claimed questions. They pointed to the pulse, the heat regulation, the structure. They asked why all of it pointed in the same direction. Not proof of intelligence, but evidence of intention. And intention is a dangerous word. Because once you admit intention, you have to ask whose. And that's when the debate stopped being technical and became philosophical. Are we observers or participants? Has the universe always been this full, and we just lack the tools to notice? Or is this truly rare? A once-in-a-civilization moment. Some argued we should protect science from speculation, that introducing ideas of artificiality would contaminate objectivity, that funding would chase headlines instead of truth. Others argued the opposite, that refusing to consider the possibility was itself unscientific, that fear of implication was shaping interpretation, and that science isn't supposed to protect comfort, it's supposed to protect truth. That sentence hung in the air. Protect truth. But truth isn't neutral. Truth changes things. It changes how we see the sky, how we see ourselves, how small or significant we believe we are. And maybe that's what this debate was really about. Not data, not models, but identity. Because for centuries, humanity has lived with a quiet assumption. We are alone. Not proven, not confirmed, just assumed. It shaped philosophy, religion, art. The idea that the universe is vast, but empty. And now, an object drifts through our solar system, silent, controlled, resilient. And that assumption trembles. No one wanted to say it outright, but everyone felt it. If this turns out to be artificial, then we are not early, we are late. Late to the conversation, late to awareness. And that thought is humbling in a way few are prepared for. So the cautious voices urged restraint. Publish nothing bold. Wait for more data. Time is on our side, they said. But time wasn't on our side. 3IATLAS was already leaving, already slipping back into the dark. Every day that passed reduced our chance to study it, to learn, to ask better questions. The awakening voices felt urgency, not panic. Responsibility. Because if this was a message, or a relic, or a machine still doing its job, then ignoring it would be the real mistake. And yet, No one wanted to trigger a false dawn. The meetings ended without conclusions. Papers were drafted, then softened. Language was revised, then revised again. Every claim shaved down until it barely breathed. Publicly, nothing dramatic happened. No announcements, no headlines, just quiet updates. But privately, the divide remained, not hostile, not angry, just unresolved, like a fault line waiting for pressure, because both sides shared the same fear. Being wrong. The cautious feared being wrong by saying too much. The awakening feared being wrong by saying nothing. And that's when the most unsettling question emerged, not from data, but from reflection. Are we protecting science, or are we protecting ourselves? Protecting our sense of place, our sense of importance, our comfort with a quiet universe. Because accepting that something artificial might drift between stars, without announcing itself, without caring who sees it, means accepting that intelligence doesn't need us, doesn't center us, doesn't even acknowledge us. That's a hard truth. Harder than aliens landing. Harder than signals screaming from the sky. Because this isn't dramatic, it's indifferent, and indifference is far more unsettling. As 3IATLAS continued its silent retreat, the debate followed it. No resolution. No consensus. Just a growing awareness that something fundamental had shifted. Not in the sky, in us. Science had done its job. It revealed an anomaly. Now humanity had to decide what to do with it. And that decision wasn't written in equations. It was written in courage, in humility, in our willingness to face implications without hiding behind caution or rushing ahead without wisdom. The debate at the edge of discovery didn't end. It paused, like everything else surrounding 3I/Atlas, waiting. Because the object may be leaving, but the questions it raised aren't. They're settling in, quietly, patiently, just like the thing that brought them to us. And whether we like it or not, the moment we notice that divide between error and truth, between fear and awakening, we crossed a line ourselves. There's no going back to the silence we once believed in. Only forward, into whatever understanding comes next. Everyone was listening, not with ears, but with instruments. Radio telescopes swept the sky. Optical sensors stared without blinking. Algorithms searched for spikes, bursts, anything out of place. If 3I/Atlas was artificial, if it was built, then surely, somewhere inside it, there would be a message. That's what we're used to. Signals are loud, obvious. They repeat until someone answers. So we listened, and found nothing. No radio transmission, no laser pulse, no encoded burst hidden in noise. Just motion. Light, heat, and silence. At first, that silence was comforting. It meant we hadn't missed anything. No danger, no call to action, just a strange object behaving strangely. But the longer the silence lasted, the heavier it became. Because silence isn't empty. Silence can be intentional. The object kept pulsing in brightness, managing heat, maintaining structure. Everything about it suggested activity. And yet, no message. No attempt to speak. No greeting, no warning. That contradiction unsettled people more than any signal ever could. Because if something wanted to be heard, it would shout. But if something wanted to pass unnoticed, it would do exactly this. Scientists searched deeper. They looked for patterns buried in a light curve, timing hidden in thermal shifts, information encoded not in sound, but in behavior. Still nothing definitive. No repeating prime numbers. No mathematical sequences. Just disciplined motion. Controlled interaction with the environment. Almost like the object wasn't communicating, it was functioning. That realization changed the question entirely. What if this was never meant to send a message? What if the assumption itself was wrong, because messages are for audiences? And nothing about 3I/Atlas suggested it cared about being seen. It didn't slow down. It didn't adjust course. It didn't react to attention. It behaved the same before discovery and after. That hurt more than silence, because it implied indifference, as if humanity wasn't special enough to acknowledge. The idea wasn't insulting, it was humbling. Think about it. If you found an anthill while walking to work, would you stop to explain yourself? Or would you just step around it and keep going? That metaphor circulated quietly, uncomfortably, because it fit. The absence of a signal wasn't a failure. It was consistency. Everything about 3I/Atlas was restrained. The pulse didn't escalate. The heat didn't spike. The reflectivity didn't flare. Nothing about it screamed. It whispered, by not speaking at all. And that forced a harder question. What if silence is the message? What if the signal is simply presence, a demonstration, not saying, we are here, but saying, this is possible? Because technology doesn't always announce itself. Sometimes it just works. Sometimes it exists quietly, doing exactly what it was designed to do. For centuries, millennia, eons, no fanfare required. That thought unsettled people deeply, because it suggested a level of maturity we don't have. Humans broadcast. We shout into the void, hoping someone hears. This object did not. It didn't seek validation. It didn't ask for contact. It moved through the solar system like a tool completing a task. And tools don't speak. They perform. The more researchers stared at the silence, the more intentional it felt. Random objects leak information. They outgas. They crack. They betray their chaos. 3I/Atlas leaked nothing. No excess energy. No stray emissions. Everything stayed within margins, as if designed to minimize footprint, to avoid detection. Or maybe detection simply wasn't relevant. That distinction mattered, because hiding implies fear, indifference implies confidence, and confidence is far more unsettling. The idea spread quietly. What if this object wasn't a probe? What if it wasn't observing us at all? What if it was infrastructure, a relay, a transport shell, a relic still following an ancient route, something that passes stars the way ships pass ports, stopping only if needed, speaking only if required, and nothing about us required it? That realization hit harder than any signal could have, because it reframed our role. We weren't the destination. We weren't even the audience. We were just nearby. Some argued we simply hadn't decoded the message yet, that it might be too subtle, too alien. But subtlety has limits. Physics is universal. And whatever this was, it wasn't trying to bridge a gap. It wasn't reaching. It was enduring, That endurance spoke volumes, because survival across interstellar space is not trivial. It requires foresight. It requires planning, and planning suggests purpose, just not communication. The silence wrapped itself around the object like armor, not empty, disciplined. Every system seemed optimized for longevity, not conversation. And that raised an unsettling possibility. What if advanced intelligence doesn't communicate the way we expect? What if speaking is a phase, one that civilizations outgrow? Maybe messages are for the young, for those still seeking reassurance that they're not alone. Maybe older intelligence doesn't broadcast. It moves quietly. It builds things meant to last, not to talk. And 3IATLAS felt old. Not in age alone, but in attitude. Calm, unconcerned, uninterested in being understood. That kind of silence carries weight. It forces reflection, because in the absence of a message, we hear ourselves, our expectations, our fears, our hopes. We want meaning handed to us, but the universe rarely does that. Sometimes it just presents a mirror and waits to see what we project onto it. The signal that wasn't sent became the loudest part of the story because it stripped away fantasy. No friendly greeting, no warning beacon, just existence. Pure and simple. And that existence challenged a deep assumption. That intelligence wants to be known. What if it doesn't? What if it simply wants to persist, to move through time and space, leaving minimal trace, as efficiently as possible? That idea changed the emotional tone of everything. This wasn't about contact. It was about coexistence, about realizing the universe might be full of things that don't care whether we notice them or not. As 3I/Atlas drifted farther away, the silence remained perfect. No final flare, no goodbye. Just steady retreat. And that ending felt deliberate. Not dramatic. Complete, like a sentence ending exactly where it was meant to. If this is a signal, it doesn't speak in words. It speaks in restraint, in balance, in the confidence to say nothing, because nothing needs to be said. And that leaves us with a question more unsettling than any message could ever deliver. If intelligence can exist without speaking, without announcing itself, without caring if it's understood, how many others are already out there, passing through, working quietly, leaving no trace, while we stare at the sky, waiting for someone to say hello? The silence of 3I/Atlas doesn't feel empty anymore. It feels intentional. And once you accept that, you begin to wonder whether the universe has always been speaking to us this way, through absence, through motion, through things that don't ask to be noticed, but change everything the moment we finally notice them. At first, the public barely noticed. A headline here, a short clip there, a strange object, unusual behavior. Most people scroll past it the same way they always do. Space news has a way of feeling distant, disconnected from daily life. Bills still need paying. Kids still need picking up. The world still spins. But slowly, something changed. Not all at once, not dramatically. Just a quiet shift in how people looked up. The idea crept in through the cracks. Late-night videos, whispered podcasts, careful interviews with scientists who chose their words a little too cautiously, unexplained, unprecedented, still under study. Those words lingered, and when people asked the obvious question, What does this mean? No one had a clean answer. That's when the unease began, because uncertainty feels different when it's close. And 3I/Atlas didn't feel far away anymore. It had crossed our solar system, past our sun, moved through our neighborhood. That made it personal. People started asking different questions, not about comets, but about us. If something artificial could drift silently between stars, then the universe wasn't empty. It was just quiet, and quiet can hide a lot. For centuries, humans have stared into the night sky and felt small. But this was different. This wasn't about size. It was about company. The realization wasn't loud. There were no riots, no celebrations, just a strange stillness. People paused longer at night, stared upward from balconies and rooftops, not expecting to see anything, but wondering. That wondering settled deep, because once the idea enters your mind that the universe may be filled with things older, calmer, more advanced, you can't put it back. Social media buzzed, then softened. The jokes came first. Aliens, spaceships, memes. That's how humans cope. But beneath the humor, something else stirred. A question no one could laugh away. What if we're not special? Not in the cosmic sense. Not the first. Not the center. Just one more moment in a very long story. That thought didn't feel threatening. It felt humbling. For some, it was awe. For others, discomfort. Religions debated quietly. Philosophers resurfaced old questions. Scientists were suddenly asked things they weren't trained to answer. What does this mean for humanity? Are we being watched? Are we late? Most answered honestly. We don't know. And somehow, that honesty made the moment heavier. Because science usually explains. It categorizes, it reassures. This time, it could only observe. And observation changes the observer. That truth became impossible to ignore. The moment we noticed 3I/Atlas, we crossed an invisible line. Before, the universe was assumed to be silent. Now, silence felt intentional. Before, space was a backdrop. Now, it felt occupied, not crowded. Occupied. That distinction mattered. People began to reflect inward. If intelligence can exist without speaking, without building monuments, without leaving obvious traces, then maybe loudness isn't strength. Maybe patience is. Maybe survival doesn't look like expansion, but endurance. That idea crept into culture, into art, into writing. A new tone emerged. Less conquest, less domination, more listening, more humility. It wasn't universal. Some reacted with fear. They wanted certainty, proof, reassurance that we were still alone, still the main characters. But even fear acknowledged the same truth. The question had changed. Not, are we alone? But how alone are we really? That's a very different question. And it has no comforting answer. Children asked their parents about it late at night, when the house was quiet. Do you think there's something out there? Parents hesitated, because for the first time in a long time, the honest answer wasn't easy. I don't know. Those words carried more weight than ever before. The sky felt closer, not physically, emotionally, like a ceiling that had lowered just enough to notice. And with that closeness came reflection. If something ancient could pass through our system without caring, what does that say about urgency? About ego? About how loudly we rush through our own short lives? 3I/Atlas didn't threaten us, it didn't acknowledge us, and that indifference forced a quiet self-examination. We like to imagine discovery as fireworks, as arrival, as contact. This wasn't that. This was a mirror held up to our assumptions, showing us how much we expected the universe to revolve around us and how little it might. The unease wasn't panic, it was adjustment. Like learning that your hometown is just one stop on a much larger map. Still meaningful. Still home, just not alone. Scientists felt it too, not fear. Responsibility. Because once the public becomes aware, you can't unshare the thought. You can't return to innocent skies. The night sky had always been beautiful. Now it was populated with possibility, and possibility is heavier than emptiness, because emptiness doesn't judge. Possibility does. It asks questions about how we treat our planet, how we treat each other, about what kind of intelligence we are becoming. Because if others exist, quietly, patiently, enduring across stars, then one day we might join that category, and the question becomes, what kind of presence will we be? Loud? Careless? Or disciplined, measured, silent when needed? 3I/Atlas didn't teach us who they are. It taught us something about ourselves, about how quickly our worldview can shift. With just a few lines of data, a few unexplained patterns, a single object passing through, observation changed us. Not because we found answers, but because we realized how many assumptions we were carrying and how fragile they were. As the object faded farther into the dark, public attention slowly moved on. News cycles changed, but the shift remained, subtle, permanent, like learning a truth that doesn't demand action but never lets you forget it. The universe didn't speak, but it didn't need to. It let us see something and trusted that we would change on our own. And maybe that's the most unsettling part of all. Nothing told us to be afraid. Nothing told us to be hopeful. We were simply shown that the universe may not be empty, and left to sit with what that realization does to us. Because if observation changes the observer, then the moment we noticed 3I/Atlas, we became something new. Not wiser, not enlightened, just aware. And awareness is irreversible. From here on out, every quiet night sky will carry that thought, that something can pass through our world without noise, without contact, without explanation, and still change us forever. And that prepares us, whether we're ready or not. If this single object has already shifted how we see ourselves, what happens when the next one comes? And what happens when we finally realize we were never meant to be alone in the first place? It leaves the way it arrived, quietly. No flair, no farewell. Just a slow retreat into the dark, carrying its pattern with it. 3I/Atlas is moving away now, past the planets, past the warmth of the sun, back into the cold space between stars, where time stretches and nothing watches. The instruments still track it, still measure its light, its heat, its motion. But with every passing day, the signal weakens. not because it's failing, because distance is winning, and that feels final in a way no explosion ever could. There is no last revelation, no hidden compartment opening. No moment where the universe suddenly explains itself. Just data, slowly thinning out until even the questions begin to fade. Scientists hoped for closure, some final clue, a breakdown, a malfunction, anything that would tip the scales one last time. But 3I/Atlas offers nothing. It doesn't unravel. It doesn't confess. It simply keeps going. And that is perhaps its final act. Not revelation, but restraint. Because proof is comforting. Proof lets us draw lines. This was natural. This was artificial. This was this, and not that. 3I/Atlas denies us that comfort. It leaves behind no signature that can't be debated, no artifact that can't be explained away, or defended, or dismissed. Just patterns, consistent enough to trouble us, subtle enough to escape certainty. And in that space between certainty and doubt, the questions live on. Was it a machine? Not a ship. Not a probe. Something quieter, built to endure, built to pass through stars the way dust passes through light. A tool with a purpose we may never understand. Or was it a relic? A fragment of something older? A piece of a civilization long gone? Drifting endlessly, still doing what it was made to do, long after its creators disappeared. A fossil still alive in motion, if not in meaning. Or was it neither? Was it something else entirely? A mirror, a test not of physics, but of perception. Something natural that only feels artificial, because our understanding is incomplete. Because we are still learning how strange the universe can be, without intelligence guiding it. That possibility is just as unsettling, because it means nature itself can mimic intention, can build things that look purposeful without purpose, and that challenges us just as deeply. The unanswered origin sits heavy, not because it scares us, but because it humbles us. Science likes endings. It likes solutions. But the universe does not owe us clarity. Sometimes it offers only encounters, moments where we glimpse something unfamiliar and are forced to admit how small our map really is. 3I/Atlas becomes fainter, harder to track. Soon it will slip beyond even our best instruments, back into a darkness so deep it might never be seen again. And that feels wrong. We are not used to mysteries leaving. We are used to chasing them, capturing them, naming them. This one refuses. It came close enough to be noticed, but not close enough to be understood, as if that distance was intentional, or inevitable, or meaningless. And that ambiguity lingers long after the object itself is gone. Because the real impact of 3I/Atlas wasn't physical. It didn't alter orbits. It didn't threaten Earth. It altered perspective. It forced a pause, a long, quiet pause, in humanity's ongoing conversation with the cosmos. For a brief moment, we weren't explorers. We were observers. Watching something older, calmer, more disciplined, move through our system without acknowledging us at all. And that is a difficult role to accept, because we are used to being central, the observers who become the story. This time, we were not. The universe did not revolve around us. It brushed past us and continued on, There is a strange peace in that, and a strange discomfort. Because if this was a machine, then intelligence exists without needing us. If this was a relic, then civilizations can rise, build, and vanish without leaving a trace we can easily read. And if this was a mirror, then our own need for meaning may be the loudest thing in the cosmos. The unanswered origin does not weaken science, it strengthens it. Because science is not about certainty, it is about honesty. And the honest truth is this: we do not know. We may never know. And that is not failure. That is reality. As 3I/Atlas fades, the sky returns to its familiar quiet. Stars resume their ancient positions. Planets continue their endless loops. From a distance, nothing has changed. But for those who watched, everything has. Because once you realize the universe can hold objects like this, silent, controlled, unexplained, you can never look at the night sky the same way again. Every dark gap between stars feels different. Not empty, just unknown. And unknown is not the same as nothing. The story of 3I/Atlas doesn't end with an answer. It ends with a responsibility. To remain curious without rushing to conclusions. To remain humble without shrinking back into fear. To accept that the universe may be filled with things that do not announce themselves, that do not care whether they are understood. Things that pass through, leave patterns behind, and vanish. And maybe that is the point. Maybe the universe does not speak in words, or signals, or proof. Maybe it speaks in encounters. Brief moments where we are reminded that we are not the oldest thing, not the most advanced, not the final chapter. Just one chapter in a story far larger than we imagined. 3I/Atlas carries its pattern onward now, into the dark, unchanged by us, unconcerned with our questions, leaving us with the hardest truth of all, that sometimes the most profound discoveries do not give us answers. They give us perspective, and that perspective stays long after the object is gone, long after the data fades, long after the sky looks quiet again. Because the unanswered origin of 3I/Atlas is no longer just about what it was. It's about what we are becoming, in a universe that has just reminded us how much remains unknown.